Molecular polarity and intermolecular forces, looking at Lewis structurals. We have phosphate over here. Phosphate has a phosphorus, which is a central atom, which is the least electronegative element compared to the oxygen, so it's going to be in the middle. There are 5 valence electrons in the middle over there. So we're going to put one phosphorus has 5 valence electrons. How many oxygens are there? Well, there's 4 oxygens. What is the valence electron number of oxygen? It will be 6. And we have 3 electrons that are added, because this means it's added 3 electrons. So you just get the sum of all of those. You end up getting 32. All right. What is the greatest common multiple of 8? Let's look over here. Without exceeding what value? It's going to be 32. We cannot exceed this number here. So this will be 32. Well, what is the greatest common multiple of 8? Well, 8 times 4 gives you 32. So that's perfect. And then we're going to subtract it by this value here that we got on the left. So you just find the difference between the two. You end up getting 0. This means that there should be 0 electrons on the outside of that central atom of phosphorus. So let's add these bonds together. Remember, we can't have this left alone because we need to have 0. So I'm just going to add this with a random oxygen. Doesn't matter which one. Now, how are we going to get the number of electrons on the outsides of these oxygens? Well, we have this one, which is double bonded, so it's 2 bonds, so it's going to require 2 lone pairs. So that's 1 lone pair, that's a second lone pair. 1 bond needs 3 lone pairs, so this is 1 lone pair, 2 lone pair, 3 lone pair, 1 lone pair, 2 lone pair, 3 lone pair, and repeat. Now let's do the formal charges. Formal charges is just the valence electron number minus the bonds of that element plus any of the dots that are alone on the outside. Well, this phosphorus over here, again, 5 valence electrons, but how many bonds are there? Well, it's bonded 5, so we're going to put 5. But are there any electrons on the outside of this phosphorus anymore? No, because they're all bonded, so it's going to be 0. So you just get the sum of all of these, you end up getting 0. Do the same thing for the double bonded oxygen over here. As shown here, it ends up becoming 0. For the single bonded oxygen up there, let's say that one. Okay, it's single bonded, ends up getting -1. This means an electron was added here. Now, you got to do it for these guys too, so I'm just going to multiply by 3 because it's the same thing, just for the sake of time. And then, now let's have a look at if this is non-polar. Well, we have to see if there's any lone pairs. So are there no lone pairs on that central atom of phosphorus? It's true, there are no lone pairs, no dots, so I'm going to put a check mark. Are there no hydrogens either? That's true, there are no hydrogens. So therefore, this is going to be non-polar. Do not forget to make sure that you have your vectors. So this oxygen is more electronegative than the phosphorus, so it's going to go in that direction. Same thing with this one, same thing with this one, same thing with this one.